All right, so I'm gonna do a quick overview of some really cool things that are happening in the R world so far as it pertains to connecting to databases. So what I have here is a script that I've written out. It's You already have access to it if you're looking at this video. And what I'm going to do is I'm going to connect to my own personal Redshift database. You also can run this script and connect to my database just like anyone else, so you can play around with some of these commands. And see some pretty cool things. So one is we're going to use dbplyr to connect to a database, run dplyr code server side that is generated into SQL. Two, we are going to see that we can use tables in a SQL database just like we would with data frames locally. And then also we're going to see that we can use SQL functions as well as dplyr functions within the same piece of code. And then we'll also be able to spit out the SQL that is generated and say like you're working with someone and they need this query to run every day. You can write it out in dplyr, print it out, and then just have them copy paste it each time that they want to run that query. So let's get started. First, if you do want to use a different database than what I'm using, just come to db.rstudio.com/dplyr and run through some of the information here. All right. So first thing first, gonna connect to the database. Like I said, you have access to this, read and write. So don't blow things up, I suppose. I've backed up my website, so I guess if you do, it's not that big of a deal. As well as, it'll show you some of the tables that you have access to here. So the first thing that we do is we connect to the public schema, and we're going to grab these two tables. So what we have here is SQL that's being generated based on the information from the database. So it's not actually being executed yet. We're just creating queries. So select star from public, .p_planes. That's it. But we can tack on SQL here just by running dplyr. So now, if we were to show the query, we would see that we've renamed. We've renamed the year to manufactured year. I did this so that we could come down and we could join these two tables server side. So we have taken this flights data, planes data, and then joined them on the server side. So now we have a somewhat bigger table being generated that we can simply just pull out and suppose campaign managers working with you and they want this query run every day. You've just made it for them in about 3 seconds. So running it on the server, let's see what happens. It's kind of a slow computer. All right, so we've taken those two tables and we've joined them together. It's created this flawless SQL code in about 3 seconds. All right, so next, we can also use SQL functions, server-side functions. So regexp replace is not a function that exists in R, but if you do want to use a function in SQL, what R is going to do is if it can't find a function with that particular name, it will ignore it as it's generating this code and assume that it's a SQL function. What the tidyverse creators are doing right now is trying to change a lot of those functions, or make those functions SQL compatible. So stringer is, frequently used to manipulate strings, right? And what they've been able to do is for some stringer functions, allow them to be compatible with dbplyr. So, it seems like every month you've got more tidyverse functions that just work seamlessly with SQL. However, if there's a SQL function that you like, you can just use it. So regex replace is, it's a SQL function, right? So we're taking the engine column, throwing in the arguments. We're going to pull out turbo. It's just redundant information. Replace it with nothing, and then we'll if the column is a character column, then we will make it all lowercase. So just a little bit of data cleaning. So here, if we run it, we haven't actually collected all the data. We're just going to get back a little bit, right? So this is still data that exists on in the database. All right, so continuing, we see that we can use more SQL functions here. So concat, we're just going to concatenate these three columns together. We're going to group by that, summarize it up, and get a count of all the flights by day. And then on the SQL side, convert it to a date instead of a character. So now we see that we have a nice summarized bit of data there. So to see that query, it's quite large, but it still works, right? It's pretty cool. So now we have this nice summarized table built off of all of the queries that we've done so far. So finally, once you're done, you've taken your 4 billion rows and summarized them into a nice 1,000 rows or so, or whatever it is that you're dealing with. You use the collect function, pull it down, and now we have that little nice table summarized up locally. So if you're an R user, you really don't need to go out and download 4 gigs of data and then load it up in your RAM. Just use your company's computers that are built to process this data, and then just pull down what you need. You can do a lot. You can you can do random sampling, server side. You can even build out models with server side commands. So like oh man, what is it? I think it's DB models. I could be wrong. No, I'm totally wrong. Hit me up if you're interested. But for example, like linear regression has very specific matrix multiplication that you can do. It's a closed form solution for a lot of different type of machine learning models, and since you know that, you can actually just run the math server side on all that data. And then pull it back and collect it. So I'll find the package if someone is interested. So anyways, this is what I want to show you. One, you can print out that SQL command. Two, you can use server-side functions as well as just do all of this as if you were working locally. So, all right. Well, I hope that was useful and enlightening.